How could a society with no permanent cities, no stone fortresses, and no forests to supply timber endure winters that routinely descend below -50 degrees Celsius on an open plain larger than Western Europe? The paradox unsettles modern assumptions about progress. We tend to associate survival in extreme cold with industrial insulation, fossil fuels, reinforced concrete, and centralized infrastructure. Yet for more than 1,000 years, Mongol families lived through winters that would disable much of our contemporary technology, and they did so using felt, animal dung, portable lattice walls, and knowledge carried in memory rather than written manuals. Archaeological surveys across the Mongolian steppe reveal seasonal camp traces used repeatedly over generations. Subtle depressions in the soil, rings of stones, post holes, compacted earth, where herds once clustered. These are not the ruins of monumental architecture, but they testify to something equally formidable, a mobile system of environmental engineering that functioned precisely because it left so little behind. To understand this achievement, one must begin with the land itself, because on the Mongolian steppe the environment was never background scenery. It was the governing force that shaped every decision long before winter arrived. In the cold season, the steppe becomes less a landscape and more a system of moving air and exposed ground. Siberian air masses sweep across treeless plains with almost no friction to slow them, gathering speed across hundreds of open miles. There are no forests to break the wind, no mountains close at hand to shield a careless settlement. The horizon offers beauty in summer. In winter, it offers exposure. Wind is the true adversary. Temperature alone can be endured with preparation, but moving air extracts heat from skin and shelter with ruthless efficiency. It penetrates seams, exploits small errors, and magnifies weakness. A structure that appears solid in calm weather can become fragile when the wind accelerates heat loss hour after hour. Survival depends less on resisting the cold than on controlling how air moves around and through human space. To an outsider, the terrain appears uniform, a rolling expanse of grassland fading into distance. Yet herders preparing for winter saw gradients invisible to the casual eye. A southern slope gathered slightly more sunlight during short winter days. A shallow depression interrupted ground-level wind currents. A modest rock outcrop redirected gusts upward, allowing the strongest force to pass above rather than strike directly. What oral tradition called finding the shadow of the mountain was not poetry. It was disciplined observation, refined across generations. Choosing incorrectly carried severe consequences. A poorly placed winter camp could mean buried herds, starved animals, and the unraveling of a family's accumulated wealth. On the steppe, geography was never abstract. It determined who endured and who did not. By late autumn, the migration toward winter ground was no longer a matter of routine movement across pasture. It became a deliberate withdrawal, shaped by urgency and restraint. Herders faced a narrowing window of time in which every decision carried weight. Remaining grass still offered nourishment, and abandoning it too early meant sacrificing valuable fat reserves that animals would need in the coming cold. Yet waiting too long invited catastrophe. An early blizzard could sweep across the open steppe and seal migration routes under deep snow, trapping entire herds far from protected valleys. Timing was not guesswork. It was informed by accumulated observation of sky color, wind direction, animal behavior, and subtle atmospheric shifts remembered from earlier years. Livestock were not passengers in this migration. They were its purpose and its engine. Sheep, goats, horses, cattle, and camels sustained Mongol life in every measurable way. They provided meat and milk through winter scarcity, wool and hides for insulation, transport across vast distances, and most critically, a living reservoir of stored energy in the form of body mass. In extreme cold, that mass translated into heat. The herd was both economic foundation and thermal infrastructure. To lose animals was not simply to lose property. It was to lose insulation, mobility, and the means to rebuild in spring. Archaeological surveys reveal that many winter camps were reused across decades and sometimes across generations. Subtle soil compaction, recurring hearth traces, and patterned stone placements suggest a continuity of occupation that points to inherited geographic intelligence. In a culture defined by portability, where structures could be dismantled and loaded onto animals within hours, permanence resided not in walls, but in knowledge. The most valuable inheritance was not an artifact handed down through bloodlines, it was memory. Families preserved an internal map of which valley concealed flowing water beneath winter ice, which slope bent the prevailing wind, and which ground allowed herds to endure when the steppe turned hostile. When the first severe storms began to gather along the horizon, Mongol households did not respond with improvisation or panic. They shifted into a pattern refined over generations, assembling themselves into deliberate, circular winter camps designed to function as a single environmental system rather than a cluster of isolated dwellings. Multiple jurs, known in the West as yurts, were positioned with precision so that each structure reinforced the next. This was not aesthetic symmetry. It was applied physics on open ground. Doors faced south or southeast, angled away from prevailing winter winds that swept down from Siberia, while still capturing what little solar warmth the low sun could offer. The gaps between structures were intentionally minimized. Separate households became a continuous barrier at ground level, where wind chill exerts its most lethal effect. By reducing open corridors where air could accelerate, the formation transformed moving wind into disrupted flow. What appeared from a distance as a simple circle of felt shelters functioned in practice as a wind-moderated enclosure. Within this ring, a protected microclimate formed. Modern thermal modeling demonstrates that even modest reductions in wind velocity can produce significant gains in perceived temperature. Historical observations describe noticeable differences between the interior of such formations and the exposed plain only yards away. The circle did not eliminate cold, it altered its behavior. At the center of this enclosure gathered the herds. Sheep, goats, and young cattle clustered together, their combined body heat radiating outward and upward. That warmth did not dissipate immediately into open space. It accumulated within the wind-shielded perimeter, subtly elevating ambient temperature. The arrangement created a layered defense, felt walls absorbing and deflecting air movement, animal bodies generating heat, families positioned along the protective outer ring. The camp became more than shelter. It became a coordinated organism, engineered to negotiate winter rather than endure it passively. The integration of animals into the camp's thermal design reveals a level of practical sophistication that is often underestimated in portrayals of nomadic life. Livestock were not simply assets gathered for protection. They were active components within a carefully balanced environmental system. A tightly clustered flock of sheep generates measurable collective warmth through metabolic heat, and when that heat is shielded from direct wind exposure, it does not immediately dissipate into the surrounding air. It accumulates within the enclosed perimeter, subtly raising ambient temperature across the protected center of the camp. The animals benefited as much as the humans. The outer ring of gears reduced wind velocity and prevented drifting snow from accumulating in lethal depths around the herd. Exposure is what kills grazing animals in winter. Wind-driven snow hardens into crust and ice, sealing pasture beneath an impenetrable layer. By moderating airflow at ground level, the circular formation reduced both convective heat loss and snowdrift concentration. In some camps, low walls constructed from stacked stone or compacted dung further stabilized the perimeter. These barriers stood only waist-high, yet their function was precise. They disrupted ground-hugging currents that would otherwise funnel between shelters and erode the thermal advantage created by the ring. Archaeological excavations reveal these elements not as monumental structures, but as patterned stone alignments and compacted organic layers. Modest in scale, they nonetheless reflect deliberate engineering. The system was not improvised in moments of crisis. It was repeatable and transferable. Livestock became living insulation, and in return, the design preserved their survival through nights when open exposure would have proved fatal. At the center of each ger stood the hearth, placed directly beneath the circular roof, opening in a configuration that appears simple at first glance, yet reflects centuries of refinement. The fire was not positioned arbitrarily. It anchored the structure both physically and thermally, creating a vertical axis around which air and daily life circulated. The Djur's circular lattice walls and gently domed profile were more than cultural signatures. They were aerodynamic solutions shaped by repeated exposure to high-velocity wind. Air encountering a curved surface flows around it rather than colliding head-on with a flat wall, reducing pressure points and minimizing structural stress during winter storms. The insulation system surrounding that central fire was equally deliberate. Layers of dense felt, sometimes reaching 10 or 12 in the coldest months, enclosed the framework. Felt is composed of interlocked wool fibers that trap countless microscopic pockets of air. Modern materials science identifies trapped air as one of the most effective barriers to conductive heat loss. Surviving fragments of historic felt demonstrate fiber density and craftsmanship capable of enduring repeated assembly, dismantling, and seasonal stress. The outermost coverings were often treated with animal fat or other water-repellent substances, preventing melting snow from penetrating and compromising the insulating core. Inside, the hearth generated a convection cycle. Heated air rose naturally toward the roof opening, carrying smoke upward and outward, while cooler air entered near floor level to replace it. This passive circulation reduced the risk of carbon monoxide accumulation without mechanical ventilation. Fuel consisted primarily of dried animal dung. In a treeless landscape where timber was scarce, dung burned efficiently, producing steady heat with relatively low smoke output. What might appear as limitation became adaptation. Every component of the Djur's thermal system worked in concert, transforming simple materials into a controlled interior environment capable of sustaining life through prolonged extreme cold. Interior organization within the GER was governed by thermal reasoning rather than decoration or personal preference. Space was arranged according to gradients of warmth and airflow that determined comfort and survival during long winter nights. The entrance, which admitted cold air each time the felt flap was lifted, marked the least protected zone. Sleeping areas were therefore positioned away from that threshold and closer to sections where heat rising from the central hearth accumulated against the curved walls. The interior was not random domestic space. It was a carefully managed thermal field. The floor demanded equal attention. Frozen ground conducts heat away from the human body with quiet efficiency. To counter this loss, layers of felt, animal hides, and dried grasses were laid down to create insulation and air gaps between earth and bedding. These materials reduced conductive heat transfer and transformed the ground from a source of depletion into a buffered surface. Even slight improvements in floor insulation could alter the body's ability to retain warmth through the night. During the most severe cold, when exterior temperatures dropped to levels capable of killing young livestock within hours, newborn animals were sometimes brought inside the ger. Their small bodies added incremental heat to the interior environment while sheltering them from exposure. Archaeological discoveries of juvenile animal bones near historic hearth sites support accounts of this practice. The integration of animals into human living space was not sentimental indulgence, it was practical necessity. Families slept in close proximity, fully clothed in heavy robes that retained insulation even while resting. Body heat was shared deliberately, adults positioned around children, elders placed nearer to the fire. In such conditions, privacy became secondary to thermodynamics. The arrangement of bodies functioned as another layer of insulation. Human presence itself became structural, an organic extension of the engineering system that allowed life to persist within walls of felt against the surrounding cold. The winter system extended well beyond the physical design of the ger and into the structure of social life itself. Survival on the steppe was never an individual enterprise. Related families positioned their gers in coordinated proximity, forming clusters that distributed environmental risk while preserving household autonomy. Each family maintained its own hearth, ensuring that if one fire failed or one structure was damaged, the entire group would not be left without heat. Redundancy was built into the social arrangement as carefully as it was built into the architecture. Knowledge moved through these kin networks with the same reliability as material goods. Techniques for managing dung fuel reserves, rotating herds to prevent overgrazing near winter camps, and responding to sudden weather shifts were transmitted through observation and lived experience. Children grew into adults within an environment where environmental literacy was constant and practical. What to an outsider might appear as informal tradition functioned as a decentralized survival system reinforced by shared memory. Severe winters known as dzud placed this framework under extraordinary strain. These events, often following summer drought, combined deep snow, extreme cold, and ice crusts that sealed grass beneath an impenetrable barrier. Modern climate data drawn from tree rings and ice cores confirm that such episodes occurred with regularity and intensity across centuries. Losses were inevitable in some years, yet pastoral life endured. That persistence suggests structural resilience rather than luck. Mobility itself was a form of insurance. When grazing failed or snow hardened beyond the ability of animals to break through, the camp could be dismantled within hours. Lattice frames folded, felt coverings rolled, herds assembled. The entire winter system could move across the landscape without leaving permanent scars. In that capacity to withdraw and reassemble lay a profound advantage. The steppe was harsh, but it was never static, and survival depended on remaining just as fluid. The same principles that sustained winter survival did not remain confined to the boundaries of seasonal camps. They shaped patterns of movement, coordination, and decision-making that later influenced broader historical developments across Eurasia. Mobility on the steppe was never chaotic wandering. It required logistical precision, timing, and the ability to assemble and disassemble entire living systems under pressure. That capacity to reconfigure space quickly and efficiently cultivated habits of discipline and collective coordination that would eventually support long-distance trade routes and, in certain periods, expansive military campaigns. It would be too simple, however, to draw a direct line from winter camp engineering to imperial conquest. Empires rise and fall for complex reasons that extend beyond environmental adaptation. What endured more deeply was a mindset shaped by climate and geography. Survival on the steppe did not depend on conquering nature or reshaping it permanently. It depended on alignment. Families selected materials that could be carried across open terrain, repaired with available resources, and repurposed when conditions shifted. Structures were temporary not because they were primitive, but because permanence would have conflicted with the seasonal rhythm of grass growth and animal migration. Every component of the winter system acknowledged change as a constant. Camps were designed to leave minimal trace, allowing land to recover and herds to return in future years. In a modern era, increasingly concerned with sustainability and environmental limits, the Mongol winter camp stands as a historical example of systems thinking long before that language existed. It demonstrates that resilience can emerge not from domination, but from a disciplined willingness to operate within constraints that cannot be altered. When spring returned and snow retreated into the soil, the circular camps dissolved without ceremony. Felt was rolled, lattice frames collapsed, herds driven toward fresh pasture. What remained on the ground were faint impressions that wind and rain soon erased. Yet the knowledge persisted, transmitted across generations not as doctrine but as practice. The endurance of Mongol pastoral life does not rest on monumentality but on repetition, on thousands of ordinary decisions made correctly in conditions where error carried fatal consequence. History often preserves stone and forgets felt, records walls and overlooks wind. But on the steppe, survival depended on recognizing limits rather than denying them, on building shelters that admitted the reality of cold instead of pretending to conquer it. If this story resonates, it may be because many families carry quieter versions of the same inheritance. Memories of grandparents who read weather without instruments, or who understood land in ways that no satellite image can fully convey. Those recollections, passed around kitchen tables or recalled in moments of reflection, are part of the same human archive that sustained life on the winter steppe. Should you feel inclined, consider sharing a memory from your own family's past, an example of adaptation or endurance that shaped who you are. In preserving such stories, We acknowledge that history survives not only in artifacts and archives, but in the lived knowledge of people who learned, sometimes the hard way, how to remain within the boundaries that nature sets.